Let's look at some formulae related to hyperbolic functions. Okay, first one, cos square x plus hyperbolic sine square x is equal to, we can say what, or since we are talking of formulae, let's write it, is equal to cos 2x. Okay, now how do we prove this? Let's go and use the exponential values, right? Cos square x is equal to e to the power of x plus e to the power of minus x by 2 plus e to the power of x minus e to the power of minus x by 2. Here both are squares, so make them square. So e to the power of 2x plus 2 times e to the power of x times e to the power of minus x plus e to the power of minus 2x by, we have to square the denominator also, so 4 plus e to the power of 2x minus 2 times e to the power of x times e to the power of minus x plus e to the power of minus 2x by 4. Denominators are same, so we can directly add them. Okay, so we have e to the power of 2x, e to the power of 2x. So 2 e to the power of 2x. This becomes e to the power of 0, which is 1, plus 2 plus e to the power of minus 2x twice. Okay, and we have minus 2. E to the power of x, e to the power of minus x is 1 divided by 4. Now let's take 2 common out. These two cancel out. We are left with e to the power of 2x plus e to the power of minus 2x by 4. So 2 cancels, and we have e to the power of 2x plus e to the power of minus 2x by 2, which is nothing but cos 2x. Now let's look at the second one, cos square x minus hyperbolic sine square x equal to 1. Okay, let's take the left hand side. Again, we know e to the power of x plus e to the power of minus x by 2 square minus e to the power of x minus e to the power of minus x by 2 square. This would be equal to e to the power of 2x plus 2 times this into this is 2 plus e to the power of minus 2x. Denominator will become 4 and 4, so we can directly keep adding. Minus 2e to the power of 2x minus 2 times e to the power of x times e to the power of minus x is 1. And we have plus, here we will have a bracket, plus e to the power of minus 2x by 4. Okay, let's open up the bracket. E to the power of 2x plus 2 plus e to the power of minus 2x minus 2e to the power of 2x. Where did this 2 come? No, we don't need this 2, okay? It is just a square. Okay, plus 2 minus e to the power of minus 2x divided by 4. This and this cancels out, and we are left with, and this cancels out. What are we left with? 2 plus 2, 4 by 4, which is equal to 1, which is equal to right hand side. Okay, in the previous two formulae we have cos square x minus hyperbolic sine square x is equal to 1. And we have cos square x plus hyperbolic sine square x equal to cos 2x. Now, if we add these two, what happens? Sin h disappears. So we are left with 2 cos square x is equal to 1 plus cos 2x, or cos, this should be cos square x is equal to 1 plus cos 2x by k, or we can write this as cos 2x is equal to 2 cos square x minus 1, because normally we would require a multiple of x. 2x we will require. Okay. Now, instead of add, if we subtract, what happens? Now, when we subtract, cos will disappear. So, if cos disappears, what are we left with? We are left with minus 2 hyperbolic sine square x is equal to 1 minus cos 2x, which becomes cos 2x is equal to, I bring this to this side, so it becomes, I bring this to this side. So 1 plus 2 sine hyperbolic square x, right? So cos 2x can be written like this or like this. Okay. Let's look at the fourth one. Hyperbolic sine 2x is equal to 2 hyperbolic sine x hyperbolic cos x. Okay. Let's take RHS now. 2 hyperbolic sine x cos x can be written as, let's go into exponential value, 2 times e to the power of x minus e to the power of minus x by 2 times e to the power of x plus e to the power of minus x by 2. One of the 2's will get cancelled and we'll be left with e to the power of x square, so 2x, plus e to the power of x minus x minus e to the power of x minus x minus e to the power of minus 2x by this, and this cancel out, which is equal to e to the power of 2x minus e to the power of minus 2x by 2, which is nothing but sine hyperbolic of 2x, which is equal to LHS. Let's look at the fifth one. Hyperbolic sine of x plus or minus y is equal to hyperbolic sine of x hyperbolic cos of y plus or minus hyperbolic cos of x and hyperbolic sine of y. We have to remember that sine iy is equal to I times hyperbolic sine y, or in the other direction, if you want to see, hyperbolic sine of y is equal to sine iy by I. Okay, let's keep that in mind. Now what we'll do is we will take the left hand side, hyperbolic sine of x plus y, and convert it into normal sine. So this will become what? Hyperbolic sine will become sine I times x plus or minus y by I. Okay. Now this can be written as, we know the identity for this, but still let me take one more step. I can write it as 1 by I times sine ix plus or minus iy. And I know sine a plus b is what? So 1 by I, let's do this, sine a cos b plus or minus sine b cos a. Okay. Now what we can also do is now go back, right? Let's convert it back to the hyperbolic sine cos. So sine ix is equal to I hyperbolic sine of x. This will become cos y. I will disappear, plus or minus. This will become I hyperbolic sine of y, and this will become cos x. Now here if you notice, we have an I here, we have an I here. We can take it out common, in which case this with the denominator it will get cancelled out. We will be left with hyperbolic sine of x hyperbolic cos of y plus or minus hyperbolic sine of y hyperbolic cos of y, which is the right hand side. Let's look at the next one, that is sixth one. Okay, now what we'll do is, we have already seen hyperbolic cos square x minus hyperbolic sine square x is equal to 1, right? Let's divide this by hyperbolic cos square x. So we need to divide every one of them. So what happens now? This and this cancels out. We end up with a 1 minus, this is what, tan, hyperbolic tan square x is equal to 1 by hyperbolic cos square x, which is going to be hyperbolic sec square x. Similarly, instead of dividing it by cos square x, let's divide it by hyperbolic sine square x. So sine h square x divided by sine h square x divided by sine h square x. What happens? This and this cancels. This is going to be cot h square x minus 1 is equal to, this is cosec x, cosec h of x square. So we have one formula, another formula. Like this you can, literally play around with this. Okay, tan x plus or minus y. This is equal to hyperbolic tan of x plus or minus hyperbolic tan of y divided by 1 plus or minus tan hyperbolic x times tan h of y. Okay, let's see how we can prove this. Let's take the left hand side. So we have tan h of x plus or minus y. This can be written as, remember conversion, 1 by I times tan I x plus or minus y. Have a look at the previous session, you will see this. Okay. Now tan we know. Anyhow, I'll write one more step. This can be written as tan of ix plus or minus iy, which is equal to 1 by I times tan ix plus or minus tan iy by 1 minus plus tan ix tan iy. This is the identity for tan. Okay. Now 1 by I, let's convert it back. So this becomes I tan hyperbolic of x plus or minus I hyperbolic tan of y divided by 1 minus plus I hyperbolic tan of x and I hyperbolic tan of y. Now here I is common, we can take it out. So I by I will cancel out. We'll be left with hyperbolic tan of x plus or minus hyperbolic tan of y by 1 minus plus this I square will become minus 1. So minus, if it is minus, it will become plus. If it is plus, it will become minus. So which means I need to reverse the, so this will become plus minus tan hyperbolic tan x and hyperbolic tan y. It's very tricky, not to miss an h. It makes a big difference if you miss a h. Okay, anyhow, so that's it.